Hello everyone, let's start with our question number 9. We have two choices. Let's start with first one. State Bohr's quantization condition of angular momentum. Calculate the shortest wavelength of the bracket series and state to which part of the electromagnetic spectrum does it belong. Okay, we, we have to state the Bohr's quantization condition and calculate the shortest wavelength, and we have to identify the part of electromagnetic spectrum. This is the definition of Bohr quantization condition. Electron revolves around the nucleus only in those orbits for which the angular momentum is some integral of h by 2 pi, where h stands for Planck's constant. So, and second one is calculate the shortest wavelength. Okay, this is the formula of finding wavelength. Lambda stands for wavelength. 1 by lambda equals to r into 1 by n square f minus 1 by ni square, whereas n is the fine nf is fine for final state and for initial. For bracket series, the shortest wavelength is for transition electron from ni equals to infinity to ni equals to 4. By putting this value, we will get 1 by lambda equals to r by 16. So lambda equals to 16 by r. And by putting the value of r, we will get 1458.5. R is a constant. We have value for r. So third one, we have to find electromagnetic spectrum. We have to identify electromagnetic spectrum. So this is the formula for, we'll get this. Okay. Okay, let's come to the second part. Calculate the orbital period of electron in first excited state of hydrogen atom. This is the formula of velocity 2 pi square by 1 by n 4 pi epsilon naught h, and this is for time period Tn. So for first excited state of hydrogen atom n equals to 2, put the value of n 2 here. So time 2 will be, calculating by this, we will get 1.22 into 10 power minus 15 second.